So, question number 6 is, in a domestic wastewater sample, COD and BOD were measured. Generally, which of the following statements is true for their relative magnitude? Yeah, so for knowing this, we should know what is COD and what is BOD. BOD is biodegradable oxygen demand, biodegradable oxygen demand, and COD is chemical oxygen demand. We can say chemical oxygen demand. This COD represents your biodegradable as well as non-biodegradable organic matters. The oxygen which is COD is the oxygen which is consumed by the biodegradable as well as non-biodegradable. So COD is biodegradable as well as non-biodegradable oxygen demand, and BOD is only biodegradable oxygen demand. So we can say definitely COD will be greater than BOD. Why? Because it is the oxygen demand COD which is having biodegradable as well as non-biodegradable obviously more than biodegradable. So the answer will be B, COD is greater than BOD. Next is, if BOD 20 degrees Celsius of wastewater is 150 milligram per liter and the reaction rate constant at 20 degrees Celsius is 0.35. We want to know what is ultimate BOD. So the formula for BOD is any BOD. For this, if we are in this question, it is BOD at 5 days. That will be L0 1 minus e to the power minus k into t, where t is the time in days. BOD 5 is given, that is 150 milligram per liter. L0 we don't know, but 1 minus e to the power. The reaction rate constant is 0.35 minus 0.35 into the time is 5. So if we calculate this, your L0 comes out to be 181.54 milligram per liter. So the answer is answer B. Next is the minimum dissolved oxygen content in ppm, parts per million, in a river necessary for the survival of aquatic life is. See, dissolved oxygen. What is dissolved oxygen? Dissolved oxygen is the amount of oxygen which is dissolved oxygen. Dissolved oxygen is amount of oxygen which is mixed in any river, so that river or sea we can say, so that it can be good for the aquatic life, right? They want to breathe, they get their food by the oxygen mixed in water. So the minimum amount of oxygen which is mixed in water, so that aquatic life can maintain, the plants can maintain, the fishes can maintain, the all the aquatic we can say creatures can maintain their lifestyle there. So that is dissolved oxygen. In any freshwater sample, DO, dissolved oxygen, is minimum 4 ppm to all the aquatic life to survive. So the answer will be 4 ppm. One thing also I want to add here, dissolved oxygen is calculated by the method which is known as Winkler's method. Alright, okay, let's check the next question, which is standard 5-day BOD of wastewater sample is nearly X% of the ultimate BOD. How much percentage of the ultimate BOD is the standard 5 days BOD? Let's try to calculate that. See, they are saying that 5 days BOD let's denote it as BOD 5. Alright, so this BOD 5 is let's say ultimate is L naught, that will be 1 minus e to the power minus k t. If I put BOD 5 is how much percentage divided by L naught is equal to 1 minus e to the power minus k into t. The reaction rate constant is almost 0.23, right? So if I put it 1 minus e to the power minus 0.23 into time is 5 days. So the value comes out to be 0.68. That means BOD 5 upon L naught is equal to 0.68. So I can say BOD 5 is 68% of ultimate BOD, that is L naught. So approximately 68%, or in general I can say that 5 days BOD, like after the reaction, after the 5 days of the reaction, the BOD which is remaining is about two-third of ultimate BOD, always, roughly we can say that. So this is the formula that we should know. This is the general concept that we should know. This is question 9. Let's do the next question. For that we need to clear the space. Next is the BOD 5 of a surface water sample is 200 mg per liter at 20 degrees Celsius. Value of reaction rate is 0.2 per day with base E. Ultimate BOD. There is only one formula that we have to apply, which is BOD 5 days only, right? Ultimate BOD is L naught 1 minus e to the power minus k into t. BOD 5 is 200 mg per liter. L naught 1 minus e to the power, reaction rate constant is 0.2 and days are 5. So if we calculate everything, we get L naught as, that means 200 divided by 1 minus e to the power minus 0.2 into 5, that means we can say 1, and it comes out to be 316.39 milligram per liter, which is similar to option D. Next is the chemical oxygen demand of a sample is always greater than biochemical oxygen demand, since it represents biodegradable and non-biodegradable organic matters, right? So it represents both. Next is a wastewater sample diluted 200 times with aeration water had an initial dissolved oxygen of 7 mg per liter. So initial DO is given. DO initial is 7 mg per liter, and after 5 days of incubation at 20 degrees Celsius, DO was 0. The BOD of wastewater is C. At the time of result, if dissolved oxygen becomes 0, that means we don't know at what time the reaction discontinued or fully over. So we can't say that what was the BOD after that. So the correct option will be there will be 4 options. So correct option will be, that we cannot determine 5-day BOD of wastewater because the data is not clear with us. So these are the next questions.